All right, so here we go. We have rate and job problems. So what are the three equations that we know for rate and job problems? If there's one person working, jobs equals rate times time. Okay? So normally they'll say so-and-so could complete one job in 10 minutes, right? One job, 10 minutes. That gives you the rate. That's their rate, right? And then you can use that later. Your keyword is can. When they say someone can do something, it means that they didn't actually do it, but they are capable of doing it. Where's the kid? She's not here. Where is she? She been gone all day? I don't like not having you guys in the morning. I feel like I lose my pulse on the 11th grade class. Like, where are you? What are you guys doing? Who's here? Who's not here? Who's eating Pringles? I don't know because I don't see you guys in the morning. It makes me sad. Hurts my heart. My day was not like warmed. My heart was not warmed by you guys being here first thing in the morning. That's true. Anyways, moving on. So, that is if there is one person doing a job. And so you would use that formula usually to find the rate. Now, if we have two people working, jobs equals rate 1 time 1 plus rate 2 time 2. In a lot of the really strange problems they gave you, the time is the same. Sometimes it's not. So you have to read carefully to see, are these times the same? Did one person work for like 3 hours more than the other? And plug those in. But generally, use this first to find the rate of somebody, then you plug it in here. If they don't tell you the number of jobs, they usually say to complete the job. So you would do 1 here. Now, what if you have more than 2 people working? Please do not sigh deeply. That's my job for once you all leave school. I sit there and I go, or if it was a good day, I go, ah. See? Yeah, it's like a release of breath to indicate finishing a job well done, perhaps. Okay, 2 or more people working, you do jobs equals workers times rate times time. The trick with that is that you assume that they all work at the same rate. So if you have like a bunch of people working, it's going to average out to them doing about the same rate. Like math problems. If I was like, we have to complete 1,000 math problems. Some of you would be a little bit quicker, some of you would be a little bit slower, but all together, you'd probably all average out to the same rate. And there's 13 of you, so there would be 13 people, about the same rate. You could figure out how much time it would take to complete those problems. Okay? So, those are your equations, and then you must just suffer through the word problems. You'll live. The other part of our lesson for today are logarithmic equations. And I think we all have this. So, how do we deal with problems with logs? Well, you might see a few of them. The most basic one you'll see is this one. So you have log base b of x equals L. Now, you have to convert that back to exponential form. Remember, base to the output equals the input, and then you solve. So if I give you a problem that was like log base 3 of x equals 9, no, that's going to be horrible. Let's do 2. How would you solve that? Well, 3 squared equals x. So x equals 9. What should you remember about logs? You can't have a negative base and you can't have a negative input. Neither of these numbers can be negative, but the number coming out can be. Okay, so let's do another one. How would you do log base b of no, that's too easy. Log base b of 1/4 equals 2. How do you solve that? Well, you convert to exponential form. So, base to the output equals the input. What would b be? Well, take the square root. Okay, which one of these is the correct answer? The positive one. Why? Because you can only have a positive for the base, and you can only have a positive, you're tapping, thank you, for the input. Okay, what are the other types of log problems that we can find? Well, we do have properties of log, but the most common other problem we will see is when you have log of something equals log of something else. What do you do here? Well, you're going to set the things inside the log equal. So x equals 2. Whatever's here should equal whatever's there, because you're plugging in the same thing to a function on both sides. Okay, what are the really hard problems? Well, you have to remember your rules of logs. So, have you learned the rules of logs yet? Yeah.
I'm gonna say I don't know what you're talking about.
Okay, cool. So this may not apply to your class. So how do we do log of A plus log of B? Yeah. Multiply. So that's log of AB. How do you do log of A minus log of B? That's log of A over B. Finally, how do you do x log of A? Well, the x in front becomes a power here. Now we have these rules because we're trying to simplify a problem that's probably very complicated down to either this case or this case. Once we get to one of these, we know how to solve it. But if we have ugly stuff, we don't know how to solve it. So we have to use the rules of logs to get one log by itself on one side. Okay, so with that, let's kick off the homework time. Homework.